Hello guys, welcome to our Capstone project, oil and gas industry Capstone project. Today we are going to dive into the comprehensive Capstone project that brings together everything you have learned about the petroleum engineering and applies machine learning to solve real industry challenges. So unlike typical academic exercise, this project integrates all three sections of petroleum industry, upstream, midstream and downstream, to a single cohesive system. This is exactly what modern oil and gas companies are doing with the digital transformation. So we are going to understand how machine learning can optimize entire petroleum value chains. We will be learning how to integrate multi-sector data for business insights. We'll apply predictive analytics to real petroleum engineering problems. We are going to develop skills in data-driven decision making. So let's start. Our first topic of discussion is problem definition and industry context. So let me start with the question, who can tell me what happens when an upstream team increases production by 20% without coordinating with the midstream transportation? So your pipeline bottlenecks, your storage overflow, and massive cost overruns. This is exactly the problem we are solving today. So our problem statement is we are going to integrate oil and gas supply chain optimization by predicting and optimizing end-to-end operations from reservoir to retail. Let me break this down. The challenge is oil companies lose millions due to disconnected operations. Upstream produces without knowing refinery capacity, midstream transport without knowing market demand, and downstream stocks inventory without production forecast. So this is a real world. ExxonMobil reported $2.3 billion loss in 2019, partially due to supply chain inefficiency. So Shell's integrated planning system saved them from $1.2 million in 2020. This is not academic. This is happening right now in boardrooms across Houston, Calgary, and Dubai. Okay, so what is our solution? So we are building an ML system that treats the entire petroleum value chain as one integrated system for predicting and optimizing from reservoir to retail pump. Okay, so let's start. Let's start this session. Okay. So what we are going to do, we are going to generate the data, synthetic data, realistic industry data. I will walk through the code step by step. Okay, so first of all, we are generating a upstream data, upstream production data. We are generating reservoir pressure, water cut, gas oil ratio, production, API gravity, all this, and we have chosen each distribution based on the actual field data. Water cut follows a beta distribution because well starts with low water production that increases over time. This isn't random, it's petroleum engineering physics. Okay, then we have added some seasonal impact also on crude oil production and natural gas production. Then we are generating the midstream data. So for midstream pipeline utilization, we have done beta distribution with high pipelines run near capacity for economics. We have done the refinery utilization. Refineries typically run 80 to 95% capacity. And gasoline yield, we have also taken care of. 45% is typical for light crude in modern refineries. Okay, so these numbers come from EIA data and actual refinery operations. As 45% gasoline yield is what you would expect from a modern complex refinery processing light sweet crude. And then comes our downstream data. Downstream data reflects market realities. For gasoline demand, just a second, guys. The third one is our downstream data. So gasoline demands 180,000 barrels per day, regional market size. Price $2.80 per gallon average reflects recent market condition and retail margin 50 cents per gallon. So accordingly, this particular thing is added. And again, we have added the seasonal impact. So this adds summer driving season demand spikes. Okay, this is the light here. So this is the complete thing. Now we are adding all the things together, combining all the data together. So let's now comes the magic integration. We'll combine all three sections together using this particular line of code. This single line creates what most oil companies struggle with, a unified view of their entire operation. And you can store this particular data frame also if you want to, just by using the f.to CSV. Okay, now we are going to add some of the derived features like profit per barrel that will be calculated as profit per barrel by taking gasoline price into 42 gallons into yield percentage, then subtracting the crude cost and processing cost. This is exactly how we find this calculate margin. Then supply demand ratio is there that we are adding. Okay. Now comes our EDA phase. So let's examine our data visually. This is where petroleum engineering meets data science. So we'll be having multiple plots here. We'll be having production trends here, seasonal pattern in the food production. We'll have the refinery utilization plots, see how it varies between 70 to 95%. Below 70% is unprofitable, above 95% is risk equipment failure. We have the demand patterns. Gasoline demand peaks in summer because it's a driving season. Diesel is more stable. Then we have price volatility. So all these things we have in this particular area, in this particular zone. Okay. And then comes our correlation analysis. Here we will be plotting our heat maps for finding out the correlation. And there are chances there will be negative correlation between crude price. We'll see the plots. I'm just showing you this particular. Okay. Next section is our machine learning model, where we will be training our machine learning models. So we are going to train linear regression, random forest, and gradient boosting. Okay. So we have selected all the features in our column instead of profit per barrel and date. And our Y is profit per barrel. Then we are doing some time-based features. We are combining day of year, month, and quarter. We're just using DT for that. And we are just updating our pictures. Nothing else. Simple thing, simple machine learning. Then we are using a standard scaler here for scaling the data. Then splitting the data into train test split. And then we'll be training our models, linear regression, random forest, and gradient boosting. All these three models will be trained. We will evaluate them by using mean square error, RMSE, mean absolute error, and R square square. Then we'll also do a cross validation over the models. We'll have the complete result with us. Okay. And after that, we are going to compare the model, all these particular models, and we are going to get the best model out of them. The best one is that is having the highest R square score. Okay. Once that is done, once model comparison is done, then our feature importance part will come. Basically, we'll be using our random forest model to get the feature importance, which feature is playing the main role. Which feature is playing the main role in determining what is my Y value? Profit per barrel. Okay. So which feature is important? So we are creating a feature block here. Then some business insight is coming into picture, where we'll see how well our model predicts profitability. Okay, so that thing will be here. I'll show you this complete thing. This will identify what makes money in the business. So the primary utilization, if it is greater than 85%, in this scenario, that is economies of scale. Optimal crude slate is higher API gravity crude. Strong product demand is seasonal peaks. Okay, all those things we are going to see. Then we have future scenario planning, predicting the future basically, running the model on the unseen data. So here we are going to test three scenarios. Three scenarios we are going to test. One is your optimistic, then is your base case, third is your pessimistic. Optimistic is higher crude prices but strong operation. Base is your current market condition, and pessimistic is your lower prices and reduced efficiency. So from there, we'll be getting the business values, we'll doing the risk assessment, understand the profit sensitivity to key variable, evaluate the project economics under different scenarios, and we are going to prepare for multiple futures. Okay, then our model prediction part will start. We'll be predicting the model, we'll set key variables to scenario values. We are going to compare scenarios for this region. Now, how would this work in real oil? So there will be data sources for your upstream, midstream, and downstream, like SCADA system, production databases, and well logs, pipeline control system, refinery DCS, point of sale system, inventory management. From that, we are going to get the data, create a ETL pipeline from operation system. We'll have a real-time processing that will stream processing for live prediction. We'll have decision support, dashboard for operation teams, and automated optimization. What a business impact it will create? It will improve 5 to 15% in margins for sure. But there are limitations also. These are static models. They doesn't adapt to changing market condition. They don't have real time, real data complexity with them. Okay, so all those things need to handle, but as it was a capstone project, I wanted to integrate all these things together. Okay, now let's run this particular project and see what's the output. It is a quick video. Crude oil production at different dates, refinery utilization in percentage, or product and demand for gasoline and diesel product demand, or crude oil price trends, or profit per barrel, negative means loss, and supply demand ratio. This is our correlation plot here. Profit per barrel and crude oil has a negative correlation. Supply demand with the gasoline demand has a negative correlation. Model is performing well, 0.99. Now, random forest will be trained, gradient boosting will be trained. These are taking little bit of time. Why? Because of the cross validation. Linear regression is performing the best out of them. A very good 45-degree actual versus predicted. Okay. So these are the business insight. Average profit per barrel is in negative, so it's running in loss right now. Average refinery utilization is 70%. Crude price is $65.48. Average gasoline demand is this. Some of the recommendations for each particular, you can integrate a LLM here for making it more robust. And these are our future profit scenarios for different cases, scenario cases that we just saw. Okay, and the quick project summary. So that was our oil and gas capstone project. Again, there are many other projects also, but these projects I'll be pushing the code in my GitHub repository. You can find out this particular all the codes in the GitHub repository. Note for this particular course, you'll be able to find out machine learning projects, machine learning oil and gas projects. Inside that, all these different projects will be there. You guys can find out and see, read, you guys can see their readme function, readme file here to understand the project. Okay. So that's all from my side, guys. And this was the end of your diploma. I hope you guys enjoyed it. Yeah, if you have any doubts, please do so on WhatsApp. And yeah, that's it. Have a great time ahead. Bye bye. Take care. Happy life.